Yes, my name is Duane and I am a Kubernetes noob, so be nice. We at Lånekassen have just started our journey entering into production about 6 weeks ago. So this is all relatively new for us. And what I'm going to try to do is, in less than half an hour, summarize a project that lasted for about a year. It's a bit ambitious, but let's give it a go. Lessons learned by migrating to Kubernetes. First off, we migrated a very small part of our system. If you go to lånekassen.no and you file out an application for a deferral of payment specifically, all that processing happens in Kubernetes. None of the others, just that specific one. It's about keeping it simple and establishing a proof of concept, because this has very much been a project about laying some technical foundations and groundwork, for obvious reasons. I'm going to talk a little bit about what I term the old stuff. People don't like me say that. We can adopt Microsoft's way of saying it. Let's call it classic. And we're going to take a look at how we do development and deployment, both for the old and new stuff, and try to contrast a little bit. And then we try to get into some lessons that we have learned, because it did not go entirely smoothly. Briefly about Lånekassen, most of you have probably heard of us, but for those that haven't, our purpose, in short, is to make education possible, mostly by providing financial support to students so that everyone has an equal chance to study and pursue higher education if they so choose. We have about 1.2 million customers. It may surprise you, we do call them customers. I'm one myself, and a lot of you are probably as well. We have about 300 employees total in the organization, and of those about 50 work in the IT department. We are primarily in Oslo or Trondheim. We have recently acquired a couple new people that exclusively work from home during the last year, and that's really exciting. What that customer base mean in terms of our systems is that we do have to manage quite a variety of applications, and during certain parts of the year there is quite a huge influx, especially during the summer. So our systems need to scale in a dynamic way. The rate of processing that has to happen is by no means stable. Shortly about me, usually you have a picture on those kinds of slides, but I figure you can see me. So I've been at Lånekassen for the last 5 years. Since 2017, I work with some DevOps stuff and some operations stuff, in brief. Not that interesting, let's move on. Starting with the beginning, as any good story, the scope of this project was, in brief, move this one very specific application, build it ground up, containerize it, and run it on Kubernetes in the cloud. In addition to all of the technical stuff that we needed to do to make that happen, moving from a VM-based platform to a more cloud-native platform. Spoiler alert, we did do it, like I said. April 1st, 2022, no joke. I made that joke, so you don't have to. Originally, it was slotted till the end of last year, but we had to postpone it quite a few times. I think 3 postponements because of a bit of technical insecurities, if you can call it that. But we have been in production with this system for about 6 weeks. So this is very much still fresh, and it's all very exciting. Briefly about the old stuff, about 60 odd VMs in our production environments, quite small scale really. All of it runs in Azure, fairly standardized in terms of load balancing, application gateways, that sort of thing. If you're familiar with it, then you're familiar with it. If not, I won't go into details regardless. We have 3 types of environments. We have what we deem test environments. The term is a bit of a misnomer. They are really dev environments, but we just adopted the word test instead. We have a pre-production environment. We have a production environment. Functionally, they're all the same. Infrastructure-wise, pre-production and production are obviously much more scaled up in terms of the amount of processing power, load balancing, that sort of thing. We do have a bit of infrastructure as code for our dev environments. We have not scaled that up to include pre-production and production because of the added complexities. And mostly that is Bicep, not Terraform. That's mainly coincidence, but that's what it is, and PowerShell. Looking briefly at the old ways of doing development, deployment, and configuration management, I made those myself. If anyone asks, I'm not an architect. That wasn't obvious. In terms of development, beginning at the left-hand side, a developer checks stuff into Git, which we host in our Azure DevOps instance. That triggers a CI build that communicates with what I've just labeled deploy app, which is a custom deployment application that we have made from scratch. We made it quite a few years ago, long before I started there, to serve our purposes of being able to deploy different units of deployments to different VMs with different types of configurations. So we still use that today. And that configuration is hosted as XML files. Recently, we introduced an API, fortunately, so we're not too reliant on those anymore. And that all turns into an artifact or unit of deployment that is registered in these custom applications that our call them end users, other developers, testers, that sort of thing, can interact with, which is the right-hand side here, where you go to this application, you select one or more packages you want to deploy. That hosts a reference to different types of configuration files that essentially tells you where this should end up, in which environment, which server, and so on. And that triggers a custom CD pipeline build in Azure DevOps. Interestingly, that is generalized to work for all of those deployments, which essentially just provides input for a backend PowerShell script that does the actual work. So those were the old ways. In terms of the new stuff, obviously workloads in pods and containers on AKS. Still, primarily Bicep and PowerShell. We just hooked the provisioning of the cluster into that existing flow because it works well enough, not optimal. Much of it is imperative instead of declarative, unfortunately. Our hosting partner, Soprasteria, has provided us with Terraform code for this, so maybe we'll start using that instead. Other stuff that we have implemented, apart from AKS, I can't go into detail on what we run in the cluster, but we run something called Dapper, which I'll get back to. We run the Nginx ingress. We run a component called Azure Key Vault to Kubernetes, which works quite well for us to sync Key Vault secrets, or secrets in Key Vault to secret objects in Kubernetes, while letting us use Key Vault as the source of our secrets. We also use container registry in Azure to host images and Helm charts. We use something called Azure App Configuration for both deploy time and runtime configuration across our services, which obviously being an Azure project integrates quite nicely with Azure Key Vault, letting you just reference secrets in Key Vault and letting Key Vault itself handle things like authorization for those objects. We use Service Bus for pub sub features, and we use Cosmos DB for state store. And we use private DNS zones and private endpoints in Azure. I don't know if any of you have any experience with that, but essentially what that lets you do is take a platform service and link it into a private network, ensuring that you can resolve a private IP for that PaaS service from your own networks instead of returning the public address, so that you have more sort of control, at least internally, of how that traffic resolves. Does anyone here use Dapper or are familiar with it? A few people, yeah. We just started using it. For those that don't know, this is very shortly. I'm not an expert, I'm not a developer, so don't arrest me on this. But it does provide a set of standardized APIs that you can use from your code, abstracting away the backend complexity and scaffolding needed to use different backend components. So you can use, like in Invoke API to do service-to-service invocation. You can use the State API to do state operations against whatever backend state store you have, and so on and so forth. And that uses a sidecar pattern. So this is a component that you deploy into your cluster. It has an operator, it has this sidecar injector, it has a bunch of other stuff, details. The point here is that this is a very central and critical part of our infrastructure that we are slightly unfamiliar with. Keep that in mind. It will become important later. Quickly going through the new ways, return of my amazing schematics. The difference now is that our CI builds during the build process push images and charts to the Azure Container Registry, as well as publishing some artifacts for use in pipelines for later. I'm skipping over tons of details because I do not have time. Sorry about that. In terms of deployment, we still use that same interface. Now, why would we do that? You have the functionality in Azure Pipelines, but if anyone has ever tried to deploy like more than, I don't know, 3, well, first of all, if you use Edge, it may crash. And secondly, that's just not maintainable. And also, we do have some less than technical people that do need to do deployment, and it's pleasant for them to be able to deploy everything from the same interface. Which is why we had to evolve an API for this service as well. So we still use that same custom deployment application to trigger the deployment themselves, which then references a pipeline backend, obviously. That pipeline, in turn, references other pipelines, which references other pipelines, potentially. Sometimes they reference a PowerShell module, which in turn inputs stuff to another pipeline. So you have X amount of potential pre-deploy steps for these services, depending on what that service will do, and that is an effort to be able to collect everything you need in a single unit of deployment. It hasn't worked fantastically well, but it was a solid effort. Let's put it that way. Another part of this is gathering configuration. I mentioned this custom deployment application and the fact that we still use that, which means that some of the configuration still resides there, and we need to pick that up in some cases. We use, as I mentioned, Azure App Configuration for deploy time configuration, and we also use Helm charts. So we do have some Helm values files. Oftentimes we use those for environment specific to separate production from pre-production from test environments, because there's usually going to be some differences for what configurations you want. You don't necessarily need as many replicas in the test environment as you do in production, and so on. So you have a huge amount of different sources of configuration, which absolutely becomes a problem very quickly. So obviously, we have been in production for about 6 weeks, and we are experiencing some pain. All of this, I mean, technically, don't get me wrong, technically it absolutely works. It's just a bit difficult to deal with. This all results in a Helm deployment to AKS. Speaking of complexity, I did mention the pipelines, and a couple of reasons for why that sort of thing happens. First off, when you don't know what you're doing, you don't know what you're doing. It's as simple as that. And if you are a bit short on time, and let's be honest, time is at a premium in any project that you do, you quickly accrue technical debt that you are not able to deal with. You're not able to do the required refactoring. You end up making a bunch of workarounds that become permanent, and so on. And this leads to angry developers who don't understand how anything works anymore. So then you and maybe one other person are able to maintain this, and that's a problem. As I said, April 1st, 2022, our first service in Kubernetes. Great success, until it wasn't. That was a Saturday. I had plans. I'm kidding, I didn't. Remember Doppel. So the way Doppel works, in a very general sense, is that to communicate with these backend Components, they use their own sort of component spec that you deploy to your cluster as YAML files, and that tells Dapper, okay, this is what you are going to connect to for this API, given this input. In our case, we use Service Bus for PubSub. We did used to use Redis streams, but people weren't too happy with that. I forget why. And we changed it last minute to Service Bus because, well, it's nice to have, when you have everything else on Azure, it's nice to have those sorts of creature comforts. You got the Azure role-based access control and stuff like that. You got the private endpoint support and so on. So it makes sense to do the switch in and of itself. These component specs can turn into a bit of a black box if you're not very familiar with reading Go code, which we're not. We're a .NET organization. We don't have any Go developers. Whatever Go code we can read is purely by chance. And we ended up in a situation where, briefly explained, Dapper just gave up trying to connect to Service Bus. It would usually take about, I don't know, maybe a day or so, and then certain pods would just stop. Said, nope, not doing this. And the solution was pretty simple, just kill it, and it works again. But that's not really what you want the day after a major release. So that was a bit of a bummer, I'll admit. We quickly, though, got to learn how to use the new alerting systems that we had in place, where we could trigger a runbook based on certain log queries. And that mitigated it pretty well, actually. But we figured out, OK, we don't actually understand what's happening. And we still don't understand why this happened as yet. We do have an issue registered for it, but I haven't kept up with it, to be honest, so I don't know how that's going. But ultimately, we decided, all right, we don't understand what Dapper is actually doing here. We have to shortcut it. So we did, and we implemented all the communication to Service Bus is now just straight through the .NET libraries. And we haven't seen anything of the sort since. So that's a bit unfortunate. Can we possibly learn something from this? Well, first off, when you have this type of diverse ecosystem, at least compared to what we're used to. Remember, we run Windows VMs, and they have their own idiosyncrasies, but they're not that complicated. And compared to this is a whole different type of world. One thing isn't necessarily easier than the other, but if you're used to one thing, you're not used to the other. At least that's our experience. So vetting all that functionality and all those chains of components can become increasingly difficult as time goes. We did actually see hints of this in one single dev environment. Just one of them. So we figured, OK, something weird's going on here. It's not easy to reproduce. We don't know what the source is. Fuck it. Well, fuck me, I guess. Apart from that, one thing we did do right, though, is that we set aside a bunch of resources right after the production release, in case something like this happened. So we were at the ready, and we were able to handle it fairly quickly, at least in terms of mitigation. So it's not all bad. Other lessons that we have learned, I've just used the term organizational maturity. If that is an actual term, I'm sorry. That's just a way to organize my notes. In terms of project planning, the interesting thing about this project is that originally it was planned in something like 2018, which is a while ago, and it was not replanned. I guess some of you may know what that means. There was no inkling of the time required to develop infrastructure at all in any of the estimates. And that's a huge problem, obviously. Obviously, that's a huge problem. So what happens? Well, there's a lot of late nights, a lot of pushback, a lot of features that you just aren't able to implement because you don't have time, because there is no room in the estimates. Luckily, we were able to shift the release date slightly because we didn't really have, mostly it was just internally agreed upon. We didn't really have any sort of external pressure to put this into production. But you can't push it too far down the line, or it will create a chain reaction. for other things that are coming. It turned out from the estimates that I've seen later on is that about 1/3 of the time we spent on what we deem as construction hours, code development, was for infrastructure. So the huge learning point that we have made abundantly clear to everyone involved in the organization is that from now on, infrastructure is development. Don't ask any questions, it just is. And that is what you need to do. You need to have a development lifecycle. It should probably be done before actual development. That would be very useful. So you don't end up in a situation where you're trying to develop the platform while the developers are working on it and the testers are trying to test the functionality. Because that is pretty problematic, as it turns out. Who'd have thought? In terms of method, we're not really organized in DevOps teams. We don't have the required organization to do that. We have developers and we have a sort of infrastructure/operations team internally. Like I said, the IT department itself is about 50 people, and that includes the entire IT department from head to toe. It is challenging to work with Kubernetes, at least establishing it, while not being able to work in a DevOps fashion, because you just don't have the actual manpower to do that, because you have other things that you need to be doing. This is just one small part of what we were doing at the time. You need to follow up on everything else that happens in production and make sure everything else runs as smooth as possible, and providing support to other types of projects that are happening and so on. So your attention will pretty easily get split. In terms of learning, take your time and accept the fact that you will fuck up. That's about all there is to it. There needs to be a room to mess up things. There needs to be a room to experiment, and most importantly, there needs to be some room to change your mind about things. Because if there isn't, you will, like I said earlier, accrue some heavy technical debt, unless you're perfect, which you aren't. A quick note in terms of people and culture. I'm not necessarily talking about DevOps culture, but one thing I notice is that when you have to crunch, which you do sometimes because shit hits the fan every once in a while, it helps sort of knowing the people you work with, at least to a certain extent. It helps to know that this person who checked in this, who broke everything, I talked to that guy earlier today about their dog or something. They had to go to the vet, I think. Maybe that's why I was distracted. But that's just more of sort of personal observation. That makes it easier for me, at least, to deal with. So that sort of thing. I've always been sort of icky about team building exercises and stuff like that, but there might be a certain value to them, at least if they happen in a more organic fashion. Don't laugh. We're all learning here, man. Fuck's sake. At a certain point in time, this will be put into productions and in the realm of operations. Now I do operations as well, so I am that same person. So if I mess up, it's my own fault. But obviously, you don't have a 100% overlap, and being able to do a neat and tidy and timely handover is extremely important. And we did not really have time for that. So the follow-up period has more or less just been an extension of the project itself, which isn't all that fortunate, because this is something that everyone should learn because it's part of our systems portfolio. In terms of learning Kubernetes, it's hard-ish. The bar can be quite high. I'm sure most of you can be familiar with that, especially if you come from a more VM-based background. It's very much not the same. In addition to all these other types of components that we are implementing, it seems obviously a bit overkill just for being able to run like, I don't know, 30 application pods or something like that. But obviously this is part of the platform now, and we are going to have to build on it. Managing expectations is incredibly important, specifically in terms of the rest of the organization and how this affects them. We have a bunch of testers, for instance, that use certain tools that suddenly will not work because it is so tightly knitted together with the older infrastructure. So how do we replace that? How do we replace this tool? How do we replace that feature and this feature and so on? Which is something we missed, basically. And I mean, we did manage to put together a solution right at the end, but we did put ourselves in a bit of an uncomfortable position there. If you're using a hosting partner, make sure your goals are aligned and that you're heading in the same direction. We did have a bit of a retrospective, and our communication with our hosting partner could have been slightly better. We did also expect a bit more technical help, where we felt we had to push a bit harder from our end to get stuff done. So that's part of the overall observations. Yeah, this is what we're going to do for now. Finding our feet, getting our bearings. We are all... I do want to stress, though, this sort of thing can become pretty introspective and a bit self-critical, because that's what's easy to focus on. But we are extremely excited about the prospects for the future, and I'm personally having a lot of fun working with this. There's so many possibilities and so much potential in this type of platform. Well, what do you think? I think it's a great idea. Right, I'm not going to spend any more time. I think I'm pretty much where I want to be.